Hello everybody, I hope you are doing well. Firstly, I would like to thank the organizers of this conference, especially Professor Belibor's College. This is Zeinab HAZBAVI. I'm working as an assistant professor and a member of Water Management Research Center in the University of HAZBAVI. My co-authors are Nazila, ALAEI, Leyla, BABAEI, and Nahideh PARCHAMI from University of HAZBAVI. Concerns over the effect of overusing and land use change have caused a serious challenge on the quantity and the quality of water and soil resources worldwide. To this end, addressing and assigning the environmental and ecological pressures play a progressively imperative role in the development of sustainable watersheds under a win-win situation. Pressures are the direct impacts of drivers and generate a range of stressors which can occur both individually and in combination at different scales in time and space. The pressures coming on the watershed could be assessed by different criteria and methodologies as presented and discussed by several researchers. We shall hear some of them. Therefore, the present paper is aimed to assess and determine the contribution percent of pressures of a semi-arid watershed located in The selected watershed is named KOZEHTOPRAGHI with mean annual rainfall of 300 mm and temperature of 7 above 7 centigrade degree, and the lowest and highest elevation is about 1,378 and 2,549 meters. The pressure index is calculated from climatic, anthropogenic, and hydrologic. The climatic criteria were mean annual precipitation, mean annual evapotranspiration, and average temperature. We selected the population density, area of agricultural land with slope higher than 25%, area under anthropogenic activity, environmental sensitive area index, and road density as anthropogenic criteria. And the slope of contribution area in runoff generation, discharge, total length of stream, and annual runoff tide was selected as criteria of. After the calculating the criteria, we did standardization using this formula. The above one is for positively sensed criteria, and the below one is used for negatively sensed criteria. The classification standard used for measuring the spatial change of the pressure index is represented also in the given table. That is valid from 0 to 1, the 0 to 0.22 indicating the high pressure on the watershed, and 0.81 to 1 indicating the low pressure on the watershed. The results show that the climatic factors, particularly the rainfall, have a vital role on the society and ecosystems. As you see here, whilst the watershed is relatively homogeneous in terms of temperature, the precipitation have high spatial trend and have the highest values in east, south, and west of the watershed. Highest population density is shown in the sub-watershed 33, center of the KOZEHTOPRAGHI watershed. The maximum and minimum road density are found at respectively sub-watershed 35, that is located in the center, and sub-watershed 17, that is located in the southwest of the watershed. The minimum values of ESA index were obtained for sub-watersheds 8 and 17 with a value of 1.18, and the maximum is for sub-watershed 13 with a numerical value of 1.53. The anthropogenic factors in terms of population density, area of agricultural land with a slope of higher of 25%, area under anthropogenic activity, and road density, not distributed evenly through the whole of the watershed, whilst the watershed is relatively homogeneous in terms of environmentally sensitive area index. The maximum slope of the contributing lands in runoff production is in the sub-watershed 17 and its minimum value is in the sub-watershed 2. The annual runoff high at the sub-watershed 2 with a value of 222 mm was the minimum, and at the sub-watershed 17 that is located in the south with a value of 215 mm was the maximum. The maximum and minimum total stream are found at sub-watersheds for the sub-watersheds 14 that is located in the southwest of the watershed and 28 that is located in the north of the watershed respectively, with a value of 135 and 0.56 km. But the results of the pressure index that is obtained from geometric of used criteria show that the intensive land use change is observed in the watershed where sub-watershed 2 are located. Some 61% of the watershed allocated to moderate pressure. The results of autocorrelation and multicollinearity also show that all of the used criteria fall into the accepted range of Durbin-Watson criterion and variance inflation factor or VIF. In general, among the criteria used to calculate the pressure index, the maximum contribution percent was allocated to the total length of stream, average temperature, population density, and area under anthropogenic activity, respectively with value of 26.52, 17, and about 24 and 12%. It could be concluded that the more pressure in the KOZEHTOPRAGHI came from hydrological factors. Conclusions. The results of the assessment and zooming of the pressure index in the KOZEHTOPRAGHI watershed northwest of Iran showed that the average and the standard deviation of pressure index is equal to 0.46 and 0.13, respectively indicating moderate pressure. The pressure index with moderate state is allocated to the 59% of the total watershed. Especially sub-watersheds in east have lower pressure rather than west. The central sub-watersheds were in moderate pressure, and the southern areas tend to be relatively high pressure. Most of the pressure on the watershed was mainly caused by human and hydrological factors. From the results of the pressure index, the policymakers have a guideline on how policy and decision makers can identify key criteria for effective decision making for integrated watershed management in the KOZEHTOPRAGHI watershed and even other similar watersheds distributed in Iran. Thank you a lot for your attention, and bye-bye.